This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. Water control at an exterior wall comes down to a simple field decision. Every upper layer must drain onto the face of the layer below it. If an upper layer is tucked behind a lower layer, the wall has a reverse lap, and water can be directed into the assembly instead of out of it. I want you to picture rain moving behind siding or through porous stucco. The cladding is the first defense, but the weather-resistive barrier is the drainage plane behind it. Once water reaches that plane, gravity should have a continuous path downward and outward. The barrier, the flashing, and the wheat path all have to agree on that direction. The memory connection is simple. Upper over lower keeps water moving outward. Lower over upper creates a pocket or a funnel toward the wall. That principle is the heart of this lesson, and it is a testable concept based on the published Contractor's State License Board Study Outline under siding and stucco. The California lapping minimums give that principle measurable field limits. Horizontal courses of the weather-resistive barrier must be installed with the upper layer lapping the lower layer by at least 2 inches. Vertical joints must overlap by at least 6 inches. The horizontal seam is where sequence matters most. I start at the bottom of the wall and work upward. Each new course covers the top edge of the course below. That is the same gravity logic used by roof shingles. Water reaching the face of the upper course crosses the seam and continues onto the face of the lower course. A correct overlap is not merely 2 sheets touching each other. The upper sheet must actually be on the exterior side of the lower sheet. A full overlap installed backward is still a reverse lap. The chart on screen separates the 2 minimums. Horizontal courses need at least 2 inches, with the upper course over the lower course. Vertical joints need at least 6 inches. I want you to remember both the dimension and the direction, because the dimension alone does not create drainage. Suppose a crew starts at the top because it seems faster to hang full sheets downward. The sheets may look smooth and complete, but every horizontal seam can end up reversed. During rain, water moving down the face of the barrier can enter those reverse seams. The material may be high quality, yet the sequence defeats the intended drainage path. At corners, repairs, transitions, and penetrations, I use the same question. Where will water land next? The answer should always be the exterior face of the layer below. Exact cutting, taping, fastening, and corner details depend on the approved plans, the code, and the barrier or flashing manufacturer. I do not turn a general lapping rule into a made-up product detail. The 6-inch vertical overlap is also a code minimum, not a suggestion to be reduced, because a seam will be covered by cladding. Water can still move behind the finish. The drainage plane must remain continuous before it disappears from view. Stucco over wood-based sheathing adds another important requirement. The assembly needs at least 2 layers of grade D paper or an equivalent water-resistive barrier recognized by the code. The layers must be installed independently so that each layer forms its own continuous plane. I do not think of those layers as a single thick sheet. I think of them as 2 separate jobs. The outer layer receives the wet cement plaster and can bond to it. The inner layer remains behind it as the more protected drainage plane against the sheathing. That distinction is the central reason a single thick-looking layer is not automatically the same as 2 independent layers. Thickness does not create separation. Independent installation creates separation. Wet cement plaster is heavy and adhesive. As it is placed and cures, it can grip the outer barrier. The practical effect of the 2-layer arrangement is that the outer layer can act as a bond breaker, while the inner layer remains available to shed water. A polymeric house wrap may be part of an approved stucco wall system, but I would never assume that a familiar wrap used behind lap siding can stand alone under cement plaster, where that wrap serves as the primary air and water barrier. I verify the required sacrificial grade D paper layer over it so the plaster does not bond directly to the wrap. Product acceptance, exact layer order, and the specified paper must follow the code, approved plans, evaluation information, and manufacturer instructions for that project. The comparison on screen shows the difference between a single combined idea and two independent planes. For stucco over wood-based sheathing, the minimum is 2 independently installed layers. In a moist climate designation A or marine climate designation C, the wall also needs either a drainage space of at least 3/16 of an inch or a drainage material with at least 90% drainage efficiency. Notice what the climate zone enhancement does not replace. It does not erase the 2-layer requirement. It is an added drainage provision on the exterior side of the weather-resistive barrier where the code applies. I also do not assume that every California project falls under the same climate designation. I verified the project location, the applicable code provisions, and the approved documents. My field supervision responsibility is coordination. I have to recognize when the enhanced drainage requirement applies and make sure the specified assembly is actually built. The extra space or drainage material supports water movement and drying. It does not rescue reversed laps, blocked outlets, or flashing that drains behind the barrier. A drainage product cannot change the direction of a bad overlap. Flashing is where a correct drainage plane is either completed or quietly broken. Windows, doors, roof-to-wall intersections, horizontal trim, and wall penetrations interrupt the field of the barrier. At each interruption, the flashing has to return captured water to the exterior drainage path. For a 2-layer stucco system, flashing intended to drain into the weather-resistive barrier system must be directed between the 2 layers. That placement gives water a route onto the drainage plane rather than behind the inner layer against the sheathing. I use a waterfall test when I inspect these transitions. I mentally pour water onto the uppermost piece. Then I follow where it would travel without relying on sealant. It should step from an upper surface to a lower exterior surface until it reaches an outlet. If my imaginary water disappears behind a lower flashing leg or behind the inner barrier, I have found a sequencing problem. Sealant still has a role where the approved detail requires it, but a surface bead is not a substitute for shingle fashion layering. The layered drainage path is what gives incidental water a way out when the exterior face is not perfectly watertight. Consider a hypothetical wall where the head flashing over a window is installed, but the weather-resistive barrier above it is tucked behind the flashing instead of lapping over its upper leg. Water traveling down the barrier can run behind the flashing and reach the rough opening. The flashing itself may be correctly shaped, but the reverse lap prevents it from doing its job. The same discipline applies to pipes, vents, electrical boxes, and other penetrations. I do not invent a universal field cut for every flashing product. I verify the approved detail and then check a principle that never changes. The finished sequence must direct water outward. At the bottom of a stucco wall, the drainage plane needs a real exit. That outlet is the foundation weep screed. It is installed at or below the foundation plate line so water behind the plaster can drain out near the base of the wall rather than remain trapped against the wood framing. The required screed may be corrosion-resistant metal or plastic. The minimum for metal is 0.019 inch, identified as number 26 galvanized sheet gauge, and the vertical attachment flange must be at least 3½ inches. The layer order at this location is non-negotiable. The weep screed attachment flange is secured to the framing or sheathing. The weather-resistive barrier laps over that flange. The exterior lath then covers and terminates on the flange. If the barrier is tucked behind the flange, water moving down the drainage plane can be delivered behind the screed and toward the sill area. That is the exact opposite of the intended exit. This is why a supervisor has to inspect the base before lath and plaster can seal the relationship. The table on screen puts the weep screed checks in a single place. The screed belongs at or below the foundation plate line. The barrier laps over its attachment flange. The lath covers and terminates on the flange. The lower edge must remain at least 4 inches above earth and at least 2 inches above paved areas. Those clearances matter after the stucco crew leaves. Soil, mulch, planter beds, and later paving can rise around the building. A screed that passed inspection during lath work can be buried during landscaping. Stucco behaves as a reservoir cladding. It can absorb and hold moisture. When its lower edge remains in contact with wet soil or mulch, capillary action can draw moisture upward. The clear space breaks that contact and keeps the drainage openings from being blocked. I use a dry sponge as the memory aid. Touch the bottom of a sponge to a shallow puddle and water climbs into it. The wall is not literally a kitchen sponge, but the comparison makes the field decision easy to remember. Keep the porous cladding and its weep path out of the wet ground. A weep screed is also not the same as a plaster stop. The weep screed is made to provide drainage at the foundation line. A plaster stop is a termination accessory and does not perform that foundation drainage function. Substituting a solid termination piece at the base can block the intended outlet. Suppose a landscaper adds a raised mulch bed after the exterior inspection and covers the bottom of the screed. Water behind the stucco may no longer drain freely, and the wet mulch can maintain direct moisture contact with the cladding. That condition can contribute to elevated moisture at the base of the wall and possible material deterioration. I would treat the final grade and hardscape relationship as part of envelope closeout, not as somebody else's unrelated work. A useful field inspection moves from the water source to the outlet. I begin by identifying the cladding and the sheathing. If cement plaster is going over wood-based sheathing, I verify the required two-layer system and confirm that the layers are independent and continuous. Next, I inspect the field laps. Horizontal seams need the minimum overlap, and the upper course must be outside the lower course. Vertical joints need their larger overlap. I look closely at patches, corners, material changes, and places where a trade stopped and another trade resumed. Then I inspect openings and penetrations. I compare the installed sequence with the approved details. Flashing that is supposed to drain to the barrier system must land in the correct plane. I do not accept a neat bead of sealant as proof that the concealed lap is correct. At the base, I confirm the weep screed location, attachment flange, barrier overlap, lath termination, and clearance above earth or paving. I also check whether later work is likely to bury the outlet. A finished patio elevation or planter design can undo correct lath work if trade coordination is ignored. Finally, I verify any climate zone drainage enhancement shown or required for the project. The extra drainage space or rated material belongs in addition to the underlying stucco barrier arrangement where the code applies. This inspection sequence is not about memorizing isolated parts. It follows a continuous line. As water enters behind the cladding, reaches the drainage plane, crosses flashing transitions, travels downward, and exits at the bottom. Every inspection point either preserves that line or breaks it. The fastest way to diagnose a suspicious detail is to ask two questions. What surface catches the water, and where does that surface discharge it? If the second answer is hidden inside the wall, the detail needs to be checked before covering. Exterior envelope work also brings a separate supervision duty: safe access. Under the California General Construction Rule, fall protection is required when an employee is exposed to a fall of 7½ feet or more from a structure perimeter or an unprotected edge. Acceptable protection can include standard guardrails, a personal fall arrest system, or safety nets, depending on the work and the applicable requirements. I do not wait for a worker to feel uncomfortable. I plan the protection from the measured exposure and the work setup. Scaffolding is required when the work cannot be done safely from solid construction at least 20 inches wide, except for the limited short-duration ladder situation recognized by the rule. The fact that a worker can reach the wall does not mean the work platform is compliant or suitable for handling paper, lath, tools, and plaster operations. The safety reference on screen shows the main field checks. The fall protection trigger is 7½ feet at a perimeter or unprotected edge. The solid working surface reference is at least 20 inches wide. Scaffold platforms use at least 2 by 10 scaffold grade lumber. The maximum listed span is 10 feet for light trades at 25 pounds per square foot, and 7 feet for heavy trades at 75 pounds per square foot. Plank overhang and overlap also have limits that must be checked before use. The scaffold requirements identify a maximum plank overhang of 18 inches and a minimum overlap of 6 inches, unless the planks are nailed in place. Those numbers do not replace a competent scaffold inspection, load classification, or the rest of the applicable safety rules. They are field checks within a larger system. A common memory error is to import a federal number or a number from another type of work and apply it everywhere. For this California general construction condition, I want you to hold on to 7½ feet. That threshold is a supervision trigger, not a target height to work just below without considering other hazards. I want to finish the technical lesson with a clean mental picture. Start at the top and imagine water moving downward. The upper barrier laps over the lower barrier. Flashing returns water to the drainage plane. Stucco over wood-based sheathing has two independent barrier layers. Where the moist or marine climate provision applies, the additional drainage space or qualified drainage material is included. At the foundation, the barrier laps over the weep screed flange and the screed remains clear of earth and paving. The key dimensions support that picture. Horizontal laps are at least 2 inches. Vertical joints are at least 6 inches. The weep screed remains at least 4 inches above earth and 2 inches above paving. Elevated work at the stated California trigger requires planned fall protection. More expensive material cannot correct a reverse lap. More sealant cannot create a missing drainage outlet. A perfect weep screed cannot work when it is buried. The assembly succeeds because every layer and every trade preserves the same outward path. There is an audio practice quiz specifically for the material in this episode. It is audio-based. The questions are read aloud and you answer by tapping, because I know you may be studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. Subscribe so I can help you stay on track through every episode until you get your license.